Today we are talking about compound events. Compound events is when two or more events happen at the same time or one event after another. There are two types, independent and dependent. An independent event is when the probability of one event does not affect the probability of another event happening. So for example, the probability of rolling a 1 on a number cube that has 6 sides is equal to 1/6, followed by the probability of drawing a 7 from a standard deck of cards. That's the probability of 1/13, since there are 4 sevens out of 52 cards in a standard deck. I take the two probabilities, and then to find the compound probability, I multiply them. So instead of drawing out the sample space, all I have to do is say 1/6 times 1/13, and that gives me 1/78, meaning that there's a 1/78 chance that I would roll a 1 on a number cube and draw a 7 from a deck of cards. Neither of the outcomes rely on the other, therefore it's an independent event. Here's another example of an independent event. Randomly picking a red shirt, khaki pants, and brown shoes from the options below. So here's our sample space. I have red, green, and blue t-shirts, jeans, slacks, and khaki pants, and brown and black shoes. The probability of selecting a red t-shirt is 1 out of 3. The probability of selecting khaki pants is also 1 out of 3. And the probability of selecting brown shoes is going to be 1/2. Now again, this is just if we were to randomly pick. So we had no clue what we were picking. We were just going in with our eyes closed and selecting. And if I did that, none of these affect one another because they're all different. So I would have 1/3 times 1/3 times 1/2, which equals 1/18. So my independent event would equal 1/18 for picking a red shirt, khaki pants, and brown shoes. Dependent events are a sequence of events in which the probability of the first event affects the outcome of the second event. This means that there is no replacement if you are dealing with something such as a cookie jar. For example, in this cookie jar, we have 3 oatmeal cookies and 12 chocolate chip cookies. What is the probability of selecting an oatmeal cookie followed by a chocolate chip cookie? So first we need to know what's the probability of an oatmeal cookie being selected. Well, there's a 3 out of 15 total cookies chance that you will select an oatmeal cookie. Then, mind you, you have taken 1 cookie out of that jar. So now you are left with 14 cookies. Now the probability of the chocolate chip cookie being selected is going to be 12 out of 14th, or 6/7. The next step is to multiply our outcomes by one another. So 3/15, which in all honesty, I should have put 1/5, times 6/7 is going to be 18 over 105. So that's 18 possible ways to get an oatmeal followed by chocolate chip, and that's out of the total number of outcomes, which is 105, and then we reduce to 6/35. In my next example of dependent events, I have a bag of marbles, and it contains 5 green, 3 blue, and 4 yellow marbles. We need to know what the probability of selecting a blue marble than a yellow marble is. So first, let's figure this out. We need to know the probability of drawing blue. That's 3 out of how many total? You're right, 12 marbles. And then we do not want to replace. We keep that marble. and we try to determine the probability of yellow marbles out of the entire bag of marbles. That leaves us with 4 out of 11 marbles. Now we multiply those and we get 3/12 times 4/11, giving us 12 over 132 possible outcomes. I'm going to divide by 12 to get 1/11. So that's 1/11 probability for selecting blue followed by yellow without replacement. In my next example, I want to know what the probability of selecting green, another green, and then blue. Now, mind you, independent events are different from dependent events. Dependent, we do not replace anything. Since we don't replace anything, we are essentially taking one away each time. So the probability of drawing a green marble the first time is going to be different from drawing a green marble the second time. The first time, the probability of drawing a green marble is going to be 5 out of 12. The second time that we draw that green marble, we are only going to have 11 marbles remaining. So that means we will have 4 out of 11 marbles that are green. And then the probability of drawing a blue marble is going to be, remember, we took one away, 3 out of 10, because there are 3 blue marbles and only 10 remaining. Next, we need to multiply them all by one another. So we multiply 5/12 by 4/11 by 3/10. 5 times 4 times 3, that would give us 60, and 12 times 11 times 10 is 1,320. I'm going to simplify them because I know that they are all divisible by 60, and we are going to get 1 over 22. So there's a 1 in 22 chance of selecting green, green, and then blue. And that's your dependent events.